Hi guys and girls, I am going to talk to you briefly about slope. This is not a new concept for you, but we have added a little bit more to this than you might have seen in the past. So first things first, what is slope? Slope really is about the steepness of a line. And it's really important that you understand that we are talking about a line. So slope only pertains to lines. What it actually means is what is the vertical change in that line when you compare it to the horizontal change. Very similar to what you did with rate of change, because this is a rate of change. But in much the same way that all squares are rectangles, not all rectangles are squares. All slopes are rates of change, but not all rates of change are slopes, because we can find the rate of change of a curve and a line, but we cannot find a slope for a curve. So this is vertical change over horizontal change. And what is very handy for us is if we can remember the little fraction rise over run. This works very well when we are talking about graphs. That's very helpful to make those a little bit easier. Now, what does the formula look like? You've seen this before. And what bothers us about this, I think, is when we see these subscripts. So we've got y2 minus y1 equals x2 minus x1. And that is for the points x1, y1, and x2, y2. And what you also need to understand is that it really doesn't matter whether it's written this way or this way, even though you've probably always written it in your notes this way. It is also fine to write it that way. It doesn't matter. Now the next question is, how do you check to see if the data in a table is linear? If you're given a table like our last example that we're going to see, to check to see if it's linear, we just want to make sure that there's a constant rate of change. So you make sure that there is a constant rate of change. Because if we have a constant rate of change, meaning if the rate of change is the same for every pair of points, the data will be linear. So this is really quick. What types of slopes are these? Well, this is not probably shocking to you. As you look at this from left to right, this thing is going up, so this is positive. You've seen this before. As you look at this from left to right, this one's going down, so it's negative. And this right here, these two are the problems that you get confused about. This one right here, the fourth one, that is a horizontal line, so its rate of change is actually 0. One way that you could remember that is if you are walking down the hallway in the school, for instance, your effort is pretty minimal, pretty easy. 0 effort, not much effort. If you were trying to scale the outside of the building, unless you're Spider-Man, you can't do that. This is undefined. That's undefined. Sometimes we might call that no slope. So I'm going to give you a second to catch up and just remind you some important concepts here. Slope is about how steep a line is. The farther the slope is away from 0, the steeper the line. What I mean by that is 3 and negative 3 have the same steepness. The difference is 3 would be going up from left to right, and negative 3 would be going down from left to right. And slope really means how do things change vertically over how they change horizontally. And that's rise over run is a nice way to remember that when we're working with graphs. And for any two ordered pairs, we find the slope by subtracting the y coordinates and the corresponding x coordinates and simplifying. And if we want to make sure that data in a table is linear, we check a couple pairs of points and make sure that it's constant. You did that in your last example from your homework over rate of change. All right, so how do we find slope? Let's see here. We are going to, I've got to get a highlighter here. We want to always start with a fraction bar and a subtraction symbol. And what always goes on the top would be the y values. So we're going to put those on top. So what has to go on top? 8 and 15, and it doesn't matter what order they're in. I'm going to do 15 minus 8 because that's less negative stuff right off the bat that I have to work with. But if I'm going to put a 15 here, I have to put its corresponding x value here. So y2 minus y1 over x2 minus x1. What corresponds with the 8? The 4 does. And you've done this before. This is not new. So if it seems like I'm going through this a little bit quickly, you are correct, but it is not new. And then for this one right here, we want to put the y's on the top. Y's are going on the top. The order doesn't matter. 2 minus negative 4. That subtraction sign is not the same as that negative. You want a fraction bar and a minus, a subtraction and a subtraction symbol. And then it's minus negative 4. If you're going to put 2 here, you have to put its x coordinate there. If you're going to put negative 4 here, you need to put the 5 here. In the past with my classes, I've always said to them, when you see this right away, that automatically means we're adding them together. So now we simplify and we get 6 over negative 13. Just leave it like that. Don't change it to a decimal. And then for this last one, no big difference other than that we're working with fractions. Start with a fraction bar and 2 subtraction symbols. I want you to go ahead and set that up on your own. And you can see here that you should have done 3 minus 7 over 7 halves minus a negative 3 halves. That negative comes from there. And then when you simplify this, this is 7 halves plus 3 halves, which is 10 halves, and that is 5. No problem. When we're working with graphs, like we have here, what I want you to do is find a place where the line crosses the coordinate plane where 2 grid lines intersect. So right there, see how these grid lines intersect right here? So I'm picking this one, and I see another one right here. It's cross where 2 grid lines cross. And then I just want you to do this. We're going to do rise over run, again with the y values. What are the y's? Y's come from our vertical change. So what is that vertical change? Let's see, pay attention to the scale here. That's 2, 4, 6, and 8. And this is 2, 4. So that is vertical change over horizontal change. Should this be positive or negative? As we look at it from left to right, it is going up, so this is a positive 8 over 4. So our slope is actually a positive 2. And the next two, if you can just look ahead and up above in your notes, what is the slope of this? Always be 0. And you probably know by now that this one, because this is a vertical segment, that will be undefined. If you want to say no slope, that's fine. Okay, moving right along. Kind of rushing you a little bit here, I think. For problems like this one's actually the hardest one because it doesn't have a specific point highlighted. Remember I said choose a point on the line where the grid lines intersect. They intersect right there, so I'm going to pick that point. And it looks like there's a spot right here. there's a point where the grid lines intersect. So what is my vertical change over my horizontal change, my rise over run? Take a look at that for a second. Again, my vertical change, I'm trying to consistently put vertical change in green. And then my there's my vertical change over my horizontal change. What is my vertical change? It's 2. Notice the scale. It's going up by $2. 2, 4, 6, 8, 10. That's 10, and specifically it's $10. And then what's this? 10, 20, 30, 40, 50, 60. So that's 60. 60 what? 60, it looks like 60 widgets. If you look up, it looks like that's 60 widgets. Sorry about that. I should have done that sooner. So our horizontal change is $10 for 60 widgets. So our simplified slope is, I think I have this done over here. Oh, wait. I did this wrong. Oh my goodness. Okay, so that's 10 over 1/6. What's 1/6 of a dollar? Let's see, 1/6 of a dollar. 1 divided by 6, in case you aren't sure, is, looks like it's about 17 cents. That's about 17 cents. So this would be 17 cents per widget. And then right here, same general idea. Trying to find a spot where it crosses at a lattice point. There's one and there's one. It doesn't matter which two you choose. Oops. My vertical change. What's my vertical change? It is, let's see, what are these going up by? 5, 10, 15, 20. So this is going up by 5. 5, 10. So that's 10. Ooh! I made a mistake. Back to number 7. I'm sorry. Too bad I caught it before you could tell me about this. That is subtraction, meaning the demand is decreasing. As the quantity increases, the price decreases. It decreases 17 cents per widget that we produce. This one's increasing $10, it looks like. $10 for every, this is going up by 1. It looks like 1, 2, for every 2 weeks. So that's $5 per week. And then the last one I'm going to let you do on your own. Number 10. Michael had a savings account. He put the same amount in the account each week. After 4 weeks, he had $350. After 9 weeks, he had $400. Rate of change of money in his savings account per week. Okay, so that's money per week. Money per week. So what would that be? Money per week. We want money on the top. So 350 minus 400. 350 minus 400. 350 corresponds to the 4 weeks. The 400 corresponds to the 9 weeks, and that gives us negative 50 over negative 5. And what that means is that we have the rate of change, that we have an increase, because it's positive, of $10 per week. The one right next to that is very similar. And then we've got this table. We want to find the rate of change in those unemployed from 2000 to 2008. You just did some problems involving that. So I will leave you at this time to get working on your rate of change and your slope homework.